Use this video to explore these three functions. I've got f of x is equal to x minus 2, and I need to make a little table. And you know what I'm going to do is I'm actually just going to carnivoralize. I'm going to steal from my other table. And I'm just going to delete these values over here, and then I'm going to make this thing. This is whatever this is. This equals whatever 1 divided by this number minus 2. Okay? So that's what I'm going to do. Alright, so let me plug in some numbers and see what I got. I'm going to go 1. I'm going to do 1.5. I'm going to do 1.75. 1.9. I'm just plugging in the numbers that they're giving me. 3 of them? Yeah. 2. 2.001. 2.1. 2.25. 2.5. 3. These ones don't exist. Alright. It looks to me... It looks to me like I've got a vertical asymptote again, and my question is, where is that vertical asymptote? Well, it's actually, it looks to me at exactly x is equal to 2. So what this kind of does, this x minus 2, it shifts that vertical asymptote to be at x minus 2, or at x equals positive 2. Because what is the domain of this function? Well, x cannot equal to 2. That's my vertical asymptote. If I were to graph this a little bit prettier, let's just do x minus 2 over here. There's supposed to be a minus there. I don't know why it's not displaying minus 2. Yeah, anyway, let's zoom out. There we go. You can kind of see this vertical asymptote happening right over here at x is equal to 2. This thing gets closer and closer and it explodes to infinity. This thing explodes to negative infinity. If I were to put an x plus 3 over there, I'm going to ask you, what do you think will happen? Well, your vertical asymptote will occur at x equals to negative 3. So x cannot equal to negative 3. Not only can it not equal to negative 3, that's where a vertical asymptote is. So you can get close to negative 3, you just can't ever equal negative 3. And you can see that in the graph here. At x equals negative 3, you can see how it explodes vertically. Alright, now this last one is really important, and I want to show it to you. 1 over x squared. In fact, let's take a look at the table, the slow table. Here we go. Alright, so I want this function to equal this number, is equal to 1 divided by this number squared. I'll drag that thing down, and I'm going to go, okay, negative 1. Negative 0.1, negative 0.001, 0.001, 1, and we'll delete these over here. Interesting. This is an interesting graph. It looks like an M. But remember, this value right here, 0, 0, I don't know why the graph plots it as 0, 0, because it doesn't actually go down, or that doesn't exist. Let's take a look at what Desmos kind of gives us. You know, I'm going to just erase this. I'm going to go 1 divided by x squared. Alright, take a look at that one. What's happening is, as you approach from the... It almost looks like the 1 over x. In fact, you know what we'll do is we'll just go 1 over x. It almost looks like the 1 over x, but you can see that we took this left-hand side and flipped it right side up. So it's not going down, it goes up as well. So when you have a 1 over x squared, the deflection goes in the same direction. Like if it's going to infinity on this side, then on the left side, then on the right hand side it's also going to go to infinity. Whereas if you have a 1 over x, then the deflection is The opposite. Whereas if you're coming in from the right-hand side, it's going to go to infinity, but if you're coming in from the left-hand side, it's going to go to negative infinity. That same property, and I actually kind of want you to discover this, but I'm just going to tell it to you now. What's going on? Is my shift key stuck? There we go. That same property happens whether that's a 3 or a 4, or no, not a 4, or a 5. Notice how the odd ones kind of give you a vertical asymptote right at, right at wherever it is you want it to be. But the point that I'm trying to make is that as you come in from the left-hand side, it deflects down to negative infinity, and as you come in from the right-hand side, it deflects up to positive infinity. Does the opposite. Whereas if you put an even power in there, then it's going to do then they're coming from the same side. I don't know if I've explained that clearly. I'm just trying to get you guys to think about this response.